What's up, Geometro Ninjas, and welcome back to another Virtual Coach lesson. Today we've got a particularly tough subject, okay, and this comes from the realm of algebra, but we're going to need to be able to master it in order to help us continue our journey around our circles. Okay, so today we're talking about completing the square, okay? And completing the square is a method of solving quadratics, so that would be the equations that have a square in them, by creating perfect square trinomials. And perfect square trinomials, and what they are, so if I remember, x squared plus 2x plus 1. Okay? If we think back to our factor, we need a number that multiplies to be 1, two numbers that multiply to be 1, and add to be 2. And then when we factor this equation down, our perfect square trinomial becomes x plus 1 times x plus 1, because 1 times 1 is 1 and 1 plus 1 is 2, which we can simplify to be x plus 1 squared. We're trying to create these guys today, because what's going to happen is we're going to manipulate our perfect squares, and it's going to help us convert the equations of circles. So let's get right into it. So completing the square. All right. In order to complete the square, so we'll have ax squared plus bx. B is just a constant, so it could be any number. Okay. In order to complete the square, in order to find our c term, so remember a quadratic is ax squared plus bx plus c, we're trying to find c. So this will be our missing term every time. Okay? And in order to find that missing term, the key lies in the b. Okay? So in order to do this, we're going b over 2 squared. Anytime I want to complete the square, I've got my ax squared plus bx, and I'm going to add b over 2 squared. Okay? B over 2 squared every time. So when I look at it, we go b over 2 squared, factors down into x plus b over 2, x plus b over 2, and that just becomes x plus b over 2. Now you're like, what, coach, what's happening? I don't understand what's going down. Like what's really happening? I want you guys to know that the number here will always be the second number of our binomial. So whatever b over 2 is, will always be the second number of our binomial. And then the full x plus b over 2 squared, that number will always, always, always become c. So while it is a little quirky, the cool thing is, no matter what, as long as I identify my b correctly, I've got my initial answer, my middle answer, and my final answer staring me directly in the face. So let's get to an example, see if we can't clear some stuff up. Find the value of c that makes x squared plus 12x plus c a perfect square trinomial. And then write the expression as the square of a binomial. So first off, we're going to take our 12, okay? Because remember, this is A, B, and C is C, so that's nice. We're going to take 12 and we're going to divide it by 2, which gives us 6. And I'm going to put a star by 6 because remember what I just said just a second ago. When we complete the square, when we do it properly, it gives us our initial, our middle, and our final answer right off the jump. So just remember this 6. You'll see it again later. You'll recognize this rascal. Okay, you'll recognize him later. So now we're going to take that 6 we just found, and we're going to square it. So 6 squared is 36. Now we're going to take 36 and we're going to replace it with c. So now our equation reads x squared plus 12x plus 36. So we just created a perfect square trinomial. So our trinomial x squared plus 12x plus c is perfect square as long as c is 36. All right, so now we're going to factor our expression. What two numbers multiply to be 36 and add to be 12? So this is where our perfect square comes into play. That c value will always be a square number. So when you're factoring it, you don't even have to go through all the other possible factors. I do not care that 9 and 4 create 36 or that 12 and 3 create 36 because those aren't square, those aren't the same number. So every time this happens, we're going to end up with, so 6 and 6, when you add them, it makes 12, and when you multiply them, it makes 36. So our two factors, x plus 6, x plus 6, we clean that up. Now, remember when I said you'd recognize that rascal earlier? Look, Coach O said it. Let's see. Who's that? Who's that? Who is that rascal? 6 is still there. So when we complete the square, that b over 2 number, b over 2 will always be the term in our perfect square binomial. Or let's say constant. How about that? Will always be the constant okay? So every time, b over 2 will always be that number. All right, let's do a couple more. Okay? Find, so first off, we're going to go b over 2 squared. Okay? So in this one, our b over 2 is negative 24. Okay? Which becomes negative 12. All right, there's that rascal. There he is. He's going to show up again later. And then that equals 144. So our expression is x squared minus 24x plus 144. We factor that down. What two numbers multiply to be 144? Add to be negative 4, or negative 24. X minus 12, x minus 12. We clean that up by saying x minus 12 squared. And uh-oh, there's that rascal. It's so awesome that everything kind of falls into place for us. All right, again, here we go. B over 2 squared. Our b this time is positive 10. So 10 over 2 squared becomes 5. Remember, he'll be in play later. There's that rascal. So our C is 25. Now when we take our expressions, we're going to factor down what two numbers multiply to be 25, add to be 10. So that's 5 and 5. Clean it up, x plus 5. Uh-oh, there it is again. Matches up perfectly. Now, all I'm worried about today is that. I am just worried about completing the square. Okay? That's going to be your homework, and then on Monday, we'll look at actually taking that completing the square and finding an equation. All right, guys, y'all have a wonderful day. Love you, and I miss you. Coach O out.